What else should cast a shadow? The measuring stick. Okay, so something like that. Okay, I get why the cactus is there. That totally makes sense. But why in the world would they have a measuring stick out in the desert? Okay, that's a great question because it's just from the drawing I have no clue. First, let me tell you what we're going to be doing. We are going to be looking at distances or heights. And we're going to measure them not using a measuring stick. Why do you think a measuring stick or even a tape measure is not always the best way to measure something? What do you think? Yeah, you have measuring tape, maybe it goes several feet, but then it stops. And then like a stick, like if I want to get the height of this building, I do something like that, right? And then, okay, that's impractical and you're probably going to make a lot of mistakes, but are all buildings only this high? No, you got really, really tall buildings and you don't have enough tape or enough of a stick to be able to measure that height. So there's got to be a better way and sometimes even a safer way to figure that out. Okay, who can read for me the second paragraph on page 208 that starts with for a geology field project? Wow, I see all those hands. I don't know who to pick. Matthew, if you could just read that paragraph for us.
For a geology field project, Elise needs to measure the distance across a deep field. The diagram shows how Elisa uses a measuring tape, a stick, and shadows to do the project. What is the distance across the gorge?
Okay, so what we're trying to figure out is what's this distance across this gorge. Why would it not be super practical to measure across that gorge with a tape measure or stick? What do you think is the impracticality or the danger?
We'd be levitating and
Yeah, either she somehow finds a way to cross over without falling through the gorge or hurting herself going down the gorge and coming back up, and maybe that tape measure or that stick isn't going to make it across, so you can't measure practically. So what is she going to use instead? She's going to use the shadow of the cactus and the shadow of a stick, a measuring stick. How in the world can she do that? All right, how tall is a cactus? 13 feet, okay? 13 feet, that's not too bad to measure. And how tall is that measuring stick? 2.5 feet. Okay, so we have the heights of the cactus and the measuring stick. Great. What did both of those objects cast? Remember what they cast?
Shadow.
And why are shadows pretty easy to measure? Yeah, they don't move after only a little bit of time, but can't you just measure that really easily? You just put a stick and you can even mark it up like that. Okay, and what did this shadow, how long was this shadow right here? I think it was 15 feet. Great. She's going to use that information right there to figure out how long it is across that gorge. Okay, but they talked about similar figures. I don't see a cactus and a stick, but that's similar figures. But do you guys see what's formed with this stick, its shadow, and if I connected the two, what shape is formed? It's a triangle. Not only is it a triangle, it's a special triangle. Does anyone know what kind of triangle it would be? It'd be a right triangle. It'd be a right triangle. That means the stick is perpendicular to the ground or to the shadow. Do you guys see it with the cactus? Do you guys see the cactus and its shadow? Does it also form a triangle? It does. And what kind of triangle? Thankfully, a right triangle. Okay, what two similar figures do I have right here? Two triangles. And they're both right triangles, and they're both similar. That means that they are proportional. Now, guys, I want you to think about this a little bit. These shadows that are cast because of these objects in the sun out there, they're going to be proportional to one another. Do you remember what proportional means? What does it mean to be proportional to one another? They relate to each other. Okay, so what does that mean proportionally? What's a proportion? How about that? Two ratios that equal each other. All right, you're like, wait, how does that work out? Well, let's check it out here. I don't know that distance across the gorge. Again, it's very impractical or even dangerous. but these two triangles are similar, so I can make a proportion. One of the proportions, this is not the only one, is 13 over x. 13 over x. That's one ratio that I can come up with. Is proportional or is equal to what other ratio? Can you give me another ratio that would make 13 over x also equal to itself? Yep.
2.5 over 15.
2.5 over 15. Are these two ratios going to form a proportion?
Yeah.
Yes, they are going to form a proportion. Okay, ready? A cactus casts a shadow. A stick casts a shadow. Those two shadows are proportional to each other. I can form a proportion. Now, that's going to get me what x is. So can you guys figure out how to work this out? What do I do here? It's a proportion. How do I find out what x is? Cross multiply. Good. And what's 13 times 15? You can work it out. 13 times 15 is a certain number. I think I heard it almost. I think it's 195. What's x times 2.5? Yeah, I'll write it like this, 2.5x. Okay, great. Now, if you had a fractional problem, what kind of answer should you get? Fractional. So I'm going to change 2.5 to an improper fraction. Do you guys remember what that would be? What's 2.5 as an improper fraction?
5 over 10.
Good. 5 halves, or 5 over 2x. So I just changed the way it looks. Now, if I'm trying to find what x is, how do I get rid of the 5 halves? What's one way to do it? Divide by 5 halves. Or multiply both sides by its reciprocal. Good. I'm going to multiply both sides by 2/5. What's 5 halves times 2/5? 1. These two fractions cancel each other out, and I'm left with x. And then what's 2/5 times 195? Well, what's 195 over? 1. So can you cancel out before you multiply? I hope so. 5 goes into 5 once. 5 goes into 195. 39 times. So really all I have to multiply is 2 by 39. That gets me 78. Now in our problem, 78 is not the actual answer. It's 78 feet. So how far is it across this gorge? 78 feet. Think about measuring that with a measuring stick. Even one that's like double this size. Is that going to be practical? No. Is that going to be safe? Think about that gorge. There's a better picture in the book. She's going to have to go through that gorge and somehow get that ruler to get above the gorge while she's in there. It's unsafe. It's impractical. Why don't you use shadows? And that's for a gorge in a desert. But do you think that applies around here? You think we can use the same stuff here? Okay. I don't have a meter stick. And I don't live in a desert. So what I want you guys to draw is a flagpole. Can you guys draw me a flagpole with the flag up top? Here's another problem. Flagpole, flag. And then I want you guys to draw a 5.5-foot person as best you can. And my people, in my drawings, are not very good, so I'm going to have to go with stick figures. That's my 5.5-foot person. You can make it more in depth, better drawn. Okay. How tall is this person again? 5.5 feet. I want to know, how tall is that flagpole? Now, what's one way you could do, figure out the height of the flagpole? Sorry? Yeah, and then how do you do? Like, how would you measure? What's like? Think if you're out there, how tall is that flagpole? What would you do? What am I doing? Climbing it up. All right, you got that? All right, we got it. Figured it out. Oh man, I hit something. I can't get up there very easily. So what else can we use to measure that flagpole without using a measuring tape to extend all the way up there? Use the shadows. In this case, the sun It's not super, it's on that last one, the sun was kind of setting or rising. It was off to the distance, but this time it's a little bit higher in the air. Oh man, and you could get into angles with these problems, but unfortunately we're going to wait till next year. Okay, and then this person also casts a shadow, right? Okay, the flag post casts a shadow of 6 feet. And the person, the 5.5 foot person, casts a shadow of 1 foot 4 inches. Oh, so you measured out, it's 1 foot 4 inches. Okay, what are we trying to find out again, guys? The height of the flagpole. What 2 similar figures were drawn up here? 2, triangles. And they're right triangles. All right, so I have 2 similar figures, but, man. What can we do to this 1 foot 4 inches? It is not 1.4 feet. This is not 1.4 feet. It is not 1.5 feet. It is 1 1/3 feet. That's correct. I'm going to change that to 1 1/3 feet. Why would I not want to go with decimals on that number, 1 1/3 feet? What's wrong with that decimal?
Because the foot is 12 inches, not 10.
Yeah, a foot is 12, so 4 over 12 would be 1/3. Do I want to use 1.3 repeating? You think I want to use that number? No. I could use 5.5 or 5.5, but not 1.33. Keep them as fractions anyway because they were a fractional problem. Can someone give me a proportion? Can someone do a proportion on that problem? Sophie, give me a proportion.
6 feet over x.
Okay, 6 over x is equal to
1 1/3 foot. And then over 5.5.
Yep. All right, now listen to me. Was that the only proportion you could have used? Okay, Sophie did this. The shadow over the actual height. The shadow over the actual height. What's another proportion you could have come up with? Hagen? Another one, not this one.
5.5 over 1 1/3.
Okay, 1 1/3.
And then x over 6.
And then x over 6. So actual height over shadow, actual height over shadow. I just need one more that doesn't use those 2. Use a different proportion. Can you do it? Is it possible? Sam?
X over 5 and 1/2.
X over 5.5.
And 6 feet over 1 1/3.
6 and 1 1/3. Good. The actual height of the flagpole, actual height of the person, over the shadow of the flagpole, shadow of the person. Do you guys see how we have parallel ideas? What is always being multiplied with x in any one of these? What's always being multiplied by x? 1 1/3. That has to be true in all of them, and it is, so we're good. All right, go ahead and solve either one. And I'm going to use, how many of you use this one? Exactly this one right here. Okay, a few of you, this one. You use that, that's the one you use. Okay, this one right here. Anyone use something different? There are other varieties. Okay, I'm going to use the top one then. It seems like most of you who raised their hand got it. All right, what's 6 times 5.5? I don't know. We'll figure that out. What's x times 1 1/3? It's 1 1/3 x. What do you think I want to do with the 5.5 and the 1 1/3 if I don't want to change them to decimals? Make them into improper. So 6 over 1 times, what do I got there?
11.
Good, 11 over 2 equals, yes, 4/3 times x, which is 4/3 x. Just make them all improper. Before I multiply 6 by 11 halves, what can I do to make those fractions a little bit easier to deal with? Natalie, what do you think?
We can reduce the 6 and 2.
Yep, so it becomes 3 over 1. And what do I get here, everyone? 33 equals. And then 4/3 x. Now, whereas we normally would say, all right, how do you undo multiplication? By dividing. But how do you undo multiplication of a fraction? multiplying by its reciprocal. That makes the numbers easier to deal with. So you got 3/4 on both sides. Cancel, cancel, cancel. Come up with x. What's 3/4 times 33? 99/4. Right? 99/4. You think that's a good answer? That's 99/4 feet tall. What do I want to do with that 99/4?
Divide by 4?
Yep, you want to do 99 divided by 4, which gives you your final answer, which makes a little bit more practical use of. You're allowed to figure it out. Okay, some of you are saying it. What do you got?
13.5.
I didn't get 13.5. I got 24 3/4 feet. So how did I do that? We just did 99 divided by 4. That's 2. Short division here, 4. And then I'm left with the remainder of 3. 24 3/4 feet. Did anyone get 24? Did anyone get 24.75 feet? Okay, that's good, but what's the answer? Yeah, so you can verify, you know 3/4 is 0.75, so yeah, 24 3/4 feet. That's how tall that flag post is. What did you need to figure out that flag post? You needed the height of the person, you needed the length of that person's, and then you needed to measure the length of the flag post's shadow. Aren't those three, the person, my shadow, and the shadow of the flagpole, aren't those fairly easy to figure out? What's the hardest one out of those to figure out? The flag post, but you can figure it out because you use those 3 other parts. Okay, it does get a little more complicated than that, but we're not going to get to that. I just want us to try one more problem. It's on page 209, and it's the try these number 1. I want to see your interpretations of those drawings. So I want to see a drawing, which is going to include a clock tower. Make it as elaborate as you want. Just don't take too much time. And then another building, which you can make it whatever kind of building you want. You're allowed to draw. And I won't criticize your drawing because who am I to criticize? My clock tower is basically a watch with a building underneath it. I'm curious though. Oh, very nice. I like the pointed steeple, the Gothic kind of like structure. It's really cool. Nice. Like the pointiness of it. It's good. Ooh, even got the little hour hand and the minute hand. I mean, that's a clock tower. Ooh, 3D on me here. Nice. What time is it according to the clock tower? Yeah, I don't know. Ooh, and the clock tower has a door into it, which is very smart. You can fix it if you needed to. And you're erasing the roofing, which was the best part of it. Nice. I like the door because it's closed. You don't want just people coming in and messing with the clock. Very nice. Yes.
Is it 50.2 the height of the clock?
That's how high that clock tower is. Yep. right, here's my drawing. Didn't want to confuse anyone. That's the clock tower. Some of you drew clocks, but I can't draw a clock very well, so. All right, which one was taller? The other building. The other building's taller. And then they give you the heights of those buildings. So the clock tower is 50.2 feet. And the other building is 125 and a half, 0.5 feet. And which shadow did they give you? They give you the shadow of the other building, and that says, I forget what it was. What's the amount? 50 feet. And they want you to find out what's the shadow of the clock tower. I don't know. Triangle. Triangle. Do you guys notice that triangles are important in math? Yeah, right triangles are even more studied because they're so vital. What's your proportion that you use, Drew? Give me one that you just used.
125.5.
125. Oh. 125.5 over.
50.2. And 50 over x.
So you did the actual height of the other over actual height of the clock, shadow of the other, shadow of the clock. That's good. What should be multiplied in this problem no matter what proportion you use? What numbers? 125.5 and x. And then 50.2, 50. Oh. What's your answer, Henry?
20 feet.
20 feet is correct. How about this? Because we didn't get to do this. Where do you think the sun is in comparison to these buildings? So, is it like at noon, straight up? Is it more over here? What do you think? How about this? I'll just stop. And you just say stop. Where do you think the sun would be about? And get a better. Okay. Basically, a backwards clock hand.
Right there.
A little bit further.
Like right here?
Yeah.
Oh. Okay, let's see. You know what's really cool, guys? We skipped 7-10. It's called trigonometric ratios. But you can actually kind of give me a better estimate of where that sun is based on those ratios. But that's more of an Algebra 1 concept. I'm going to figure it out. I haven't looked it up. I'm going to figure out where it should be about. You don't have to do that, but I'm curious now about that problem. Okay. Goodbye, Swivel.